Hi, Soyalajan. Hi, everybody.
Hi, Dr. Khaazraeian. Welcome to our webinar.
Thank you. Let me turn on my video.
Thank you so much.
So it seems like we have a full house.
Yes, hopefully, yes.
Yep.
Okay.
They would do all this stuff together, Go to the beach and, they'd be doing this yoga poses.
At the beach and
Yeah,
sunset
yeah.
and all that.
It's, wow.
The students are coming and let us, the other students,
Yes.
join.
Reach out to, and he asked her if she was, but yes, and she was really like, yeah. Oh, I don't think he's really, nothing.
So
So I think we can start, and we are really proud to talk about the new concept in the transportation field. Yes.
Yeah. So should I start?
Yes.
Okay. Let me introduce myself first.
Mhm.
Hi, everybody. Thank you for joining my presentation today. My name is Khaazraeian, and I am an ITS engineer in the Stantec company. I graduated with my PhD in 2017, and since then started working for Stantec. I work on a wide range of ITS projects around the world. And today I'm going to show you some of the projects and give you an idea of type of projects that you might be working on when you graduate and join a consulting company. So let me go and share my screen here. Okay, yeah. Can you see my screen?
No. Right now, yes.
Is this the correct screen? Because I cannot see which one is shared. Is it the full screen you see?
Yes, it is full screen.
Okay. Here is just some information about the Stantec company. We have over 25,000 employees around the world and 400 locations, offices around the globe. We have won different awards, and these are the offices on the map. As you see, we have a really huge presence in North America. We have some presence in Europe and in Middle East as well. And these are the projects, the ITS projects that we have done so far. And these are the ones that I've been involved in. And I am going to show you some of maybe 5 of them today. The first one is, let me see, this was the first one. Okay, here. So there were a couple of projects in Dubai that I started with when I joined Stantec. They were related to self-driving cars and also the code of practice for autonomous vehicle operation in Dubai. I've done some projects in Australia recently related to pedestrian detection technologies and safety cameras using AI to detect the driving offenses. Some projects in North America, including Colorado Track Safety Information System, Oklahoma TMC design, Las Vegas AV ecosystem, South Dakota ITS deployment, and Tennessee software update. I'm gonna go through each one briefly, and you can ask me any question. Either you can stop me or you can ask your question at the end of the presentation. These are the type of ITS services that we offer. Traditional ITS, roadway planning, design and implementation, smart mobility and CAV consulting, research and feasibility study for ITS projects, TMC design and software replacement projects, and public and mass transit ITS. I have been mainly involved in the smart mobility and research and development projects since I joined. The most important part of any ITS project is system engineering analysis. You have probably studied this in one of your courses. This was offered when I was a student at FIU. We had a course on ITS, and system engineering analysis was a subject there. So it's important to learn that. That time I didn't have any idea. I just studied that, didn't have any vision about system engineering analysis. And when I started working on it, I realized that it's very important to understand the concepts. And I'll tell you what is the concept. So this V diagram is a framework that you have to follow for any ITS project that is federally funded. So basically you have to develop system engineering analysis documents to get the funding from the federal government and do your ITS project. And I think there was background noise. Okay. Each step has to be completed and a report has to be created for that step and submitted to the federal government. And the purpose of this system engineering analysis is to mitigate the risk of project failure. So we do the planning beforehand and we know the problems, we talk to the stakeholders, and we bring everything up front. So there is the risk of the project failure in terms of schedule and budget is minimal. And through this process, we bring all the stakeholders together and we ensure that we have a common understanding of the projects and the needs of the project. And this system engineering framework would identify user needs and system capabilities at a high level and bring it to a simple language so stakeholders from a wide range of entities would understand the project, the problems, and the needs. One of the projects that we performed system engineering analysis for was Norman Traffic Management Center design. Norman is a small city in state of Oklahoma, and they have a small network of arterial and just one freeway. And they wanted to be able to manage the traffic and incidents in that city. There was no TMC, and we started designing the TMC. First, we completed the system engineering analysis, submitted the system engineering analysis documents to the federal government, and then got the approval to build the TMC. And here is the big picture of the TMC we designed. In the heart of the picture is the TMC, and all the entities, elements, and vehicles that talk to the TMC and get the data, basically exchange the data with the TMC. You see here on the top left, these are different centers that talk to the TMC, and for any reason, for incident management, any type of data can be transferred to these agencies via an agreement. So City of Norman Traffic Control Center, ODOT Virtual TMC, Norman Police Department, County Sheriff, because police and sheriff, they have a tight relationship with TMC for the purpose of incident management. And these are the devices that communicate with the TMC, and they are connected to the TMC. Traffic signals, CCTV cameras, Bluetooth detectors, dynamic message signs, roadside units for the connected vehicle applications. It is a future application, is not yet in the place, and vehicle detection systems. Some centers can communicate with the TMC using fiber and some through cellular communication or wireless communication. And emergency vehicles also can communicate with the TMC over cellular network. And here is an idea that we came up with for the city of Norman, because it is such a small city and we didn't really want to invest a lot of money on TMC development. You may know that a video wall costs $1 million, and it is a really huge investment for such a small city. So we came up with this mini TMC idea. So each desk is a mini TMC for the TMC operator. They have a small video wall on the top, and they have the monitors to do their daily job. And we called it ITOC, Integrated Traffic Operation Console. And the city liked it, and they are basically, we are designing it and it's being completed like in the next year, and the city would have 3 of these consoles, and they can add to the consoles if they had more need and they wanted to hire more operators. Here is the Colorado I-70 truck safety information system that I talked about. Colorado is a mountainous state. They have opposite of Florida, which is like a pancake. They have a lot of mountains, and a lot of truck drivers get into downhills. They have no idea. Let me close this. They have no idea that there is 6 to 8% of downgrade, and they lose their brake and they slam into other cars and create horrible accidents. So in this section of I-70 that we looked at, there were 2 sections that had a serious downgrade, like 6 to 8%. And we thought that we can give the drivers, the truck drivers, a heads up, a kind of in-cab message to the driver saying, there is a downgrade ahead, reduce your speed, this is your safe speed. And here is the architecture of the system that we propose. As the truck gets close to the downgrade, we weigh the truck using the weighing motion system, and we read the license plate using the cameras, special cameras for license plate reading. And if the truck is overweight and the speed is higher than what it should be, we send a message on the display board. They have a kind of ELD system for their logging. It's a logging system for the trucking business, electronic logging device. They have to check in and check out. But we can utilize that device and send a message, a yellow message, which is a warning, on their display saying, truck plate number such and such, your safest speed is this much. And this is a personalized message for the truck driver. It's not a general message that is sent to everybody. It is targeted for that driver, which is overweight and overspeed. So there are a lot of things here to be designed. I just showed you the big concept, but you can ask me questions if you have any. And this is just showing the ELD and the message, the type of message on the ELD for the driver. The next project is the Tennessee TMC Central Software Upgrade. Tennessee has 4 different TMCs, Nashville, Knoxville, Chattanooga, and Memphis. And they all were operating on an old system. Each device was controlled using a different piece of software. For example, CCTV cameras were controlled using Chameleon software. Dynamic message sign was controlled through another software. And it was not really integrated in one pack of software. And the operator had to log into different softwares and control different devices. And what we did for Tennessee DOT was a unique software with a mapping feature that the operator can simply click on the map. The next slide. Can simply click on the map and see different devices. And the operator would have a menu like this for each subsystem or device, for CCTV, for RAM metering, for any type of ITS device or strategy to control and manage. And it is all unified, which is the most important part of this project, a unified system for controlling ITS devices over the roadways. And what we did, again, this project was a federally funded project, and we used system engineering analysis to complete the project planning and design. And a part of system engineering analysis, as I said, is stakeholder engagement. For this project, because it was such a huge project, like 5-year project, $5 million, we had to have meetings with the stakeholders, which were like 30 people every month. So I would fly to Tennessee every month, and we had meetings with this group. And we would get their input on the project process, what we have done so far, what they think, if their needs are met. And the stakeholder included the TMC managers, TMC operators, TDOT managers, a wide police department, fire department, because they were all involved in the TMC operation and they would benefit from it. So we wanted to get all their opinions before designing a software, because when you design a software, you add a menu, for example, you don't want to go and change it. It's extra work. We wanted to have all the opinions beforehand and deliver something that makes all the stakeholders happy. This project is an AV ecosystem in Las Vegas. So Las Vegas has a medical district that includes medical facilities, hospitals, universities, and each year it would serve more than 200,000 patients. And they really didn't have a really safe mode of transportation for the patients. What we came up with was 4 different self-driving shuttles. We introduced 4 self-driving shuttles into that district, so that the patients can take that shuttle, which is very low speed, like 35 miles per hour, and they can circulate in the medical district between hospitals, medical facilities, wherever they want to go. And this blue line shows the AV route, and there are, I guess, 9 AV bus stops. And the shuttle stops are also smart. We came up with a smart shelter design that includes multiple technologies, from Bluetooth passenger counts, CCTV cameras, announce theaters for people saying, for example, the shuttle is coming in next 5 minutes, smart lighting, smart trash can, cellular modem, and different IoT devices, basically. And on the top of it, I'll get to the shelter later, but other than the 4 AV shuttles, we had 23 smart shelters, 20 roadside units, 25 onboard units. It's not a really connected vehicle, real connected vehicle. These are test connected vehicles. So we had 25 test OBUs and 5 pedestrian detection systems at 5 select intersections. And this is a smart shelter I talked about. And here is the data flow between different elements of this project. We had connected vehicles, we had pedestrian detection system, we had traffic signals, smart transit shelters, and AV shuttles. These 5 elements all connected to a data hub, which is designed and operated by the client of Las Vegas. And this data hub also feed data to the third-party apps. For example, something like 511, or which is called Go Vegas. Any other third-party app that would benefit from this data, they could be connected to the data hub and receive the data from all these elements. And these elements talk to each other as well. For example, pedestrian detection system would talk to the traffic signal and send information on the presence of a pedestrian on the crosswalk or the wait zone, and the traffic signal can change the crossing time or any other thing according to that transaction. And also, the pedestrian detection system talks to the connected vehicle. If there is a pedestrian on the crosswalk, the pedestrian detection system would send a message to the onboard unit of the connected vehicle so that the vehicle knows there is a pedestrian crossing, and so on and so forth. Dubai World Challenge. Dubai is rich, right? They want to be first in everything. And they have defined a challenge for self-driving transport so that they can bring the best of the best to Dubai. The first part of the challenge was on first and last mile delivery. A self-driving shuttle is one of those. And they wanted to have a competition between different shuttle manufacturers and pick the best one and have a contract with that shuttle manufacturer and bring it to Dubai. So what we did for the Dubai government was designing the evaluation criteria for the selection. We had to design different templates, design questions, talk to the AV shuttle manufacturers, and basically evaluate them and rank them so they can pick one. And we did all the process, and at the end there was a Dubai Congress on self-driving transport back in 2019, and there they announced the winner of the competition and had a contract with the shuttle manufacturer, and they wanted the shuttle to be operating in malls, airports, campuses, because these are really low speed and cannot be used for other purposes. Should be in areas where people are patient sitting in a really slow moving vehicle. South Dakota, I-90, ITS deployments. South Dakota has really harsh winters. They have, let me bring that, okay, I don't have, yeah. So they have really bad accidents during winter on I-90, and they didn't really have an ITS solution or any ITS system that can help reduce the accidents and warn the drivers about bad weather condition or any type of ITS system that could help improve safety on I-90. What we did, first project goals, we wanted to enhance the safety along I-90 during congestion, work zone, special event, and adverse weather, with a focus on adverse weather condition to be able to manage accidents and response timely, and also provide traveler information system by integrating all those ITS devices into their 5x1 system, and also Safe Travels USA, another system they have for traveler information system. And that corridor of I-90 also has huge truck presence, which makes the accidents even worse. And they also have a yearly motorcycle rally, which creates huge congestion. That is another problem we wanted to address. What we came up with was a range of ITS systems, including CCTVs, queue detection for the main line, vehicle detection system, dynamic message systems, variable speed limits, and road weather information system. So the variable speed limit was an important part of the project, especially, as I said, during winter. And here is the design of the schematic of the ITS development for the I-90. It's pretty crowded. It shows all the signs, the power station, where they get the power, the fiber line, and anything that we designed is shown on this schematic. This is a project in Australia about pedestrian detection technologies. In Western Australia, they have huge pedestrian activities, and they wanted to have the client, which is Main Road Western Australia, wanted to have a pedestrian detection system that automatically detects the pedestrian in the wait zone and the crosswalk, and communicate that to the traffic controller, the signal controller, so the signal controller can either increase the crossing time for elderly people, let's say, or even reduce it if there's a bicyclist that needs less time to cross the intersection. So the main purpose was to extend the crosswalk and also cancel the pedestrian call if, for example, the pedestrian pushes the button and walks away. So that pedestrian does not need to be served. And if we serve that phase, a lot of delay would be imposed on the vehicle side. So the purpose was to make the intersection operation more efficient using the pedestrian detection system. We looked at different technologies to do this detection, including thermal imaging, LiDAR, and optical cameras. Thermal imaging, as you may know, works with the temperature difference. Basically, if you see the top left image, it's a thermal image that's captured by a thermal sensor. And it shows the temperature difference of the objects in the environment, and the detection is done using the temperature difference. It doesn't need a really high quality image. Like, for example, optical cameras need a really high resolution image to do the detection, do the image processing, but thermal imaging doesn't need that, and also is robust to different lighting and weather condition. They can work in dark, in rain, in snow, in sun glare. The optical camera does not work well in sun glare. It gets blind, or in darkness, shadow, snow, rainy condition. So thermal imaging has a lot of benefits over optical for this purpose. LiDAR actually was not a good option for this case because it needs a really huge processing power. Every second it produces a terabyte of data. We really didn't need that huge data processing power here, and we could do it with thermal imaging, simply with thermal imaging. So this option was eliminated. And optical camera was another good option. There are a lot of advances in optical cameras and the way they do the image processing using AI, but it was a bit expensive compared to thermal. So eventually we picked thermal camera for Western Australia, and we bought a couple of thermal cameras to do testing in their lab before rolling it out to the whole network, transportation network. The next project is the safety camera that I talked about. The safety camera that we evaluated for Western Australia was AI enabled. So as you see, there were 2 cameras on the top and 2 cameras on the side to take multiple images of the vehicle and see if the driver is holding a cell phone or is wearing the seatbelt or not. And the whole purpose was to detect the traffic driving offenses, basically driving offenses, and generate a fine automatically for that driver and increase safety in the Western Australia network. And it was a portable station rather than a fixed location, because if it was fixed, the drivers would know about it and they would correct their behavior. We didn't want that. We wanted to catch them off guard and really know if they are being a good driver or not, especially holding a cell phone while driving, which is really dangerous. And we really cared about holding the cell phone and looking at the cell phone, then generate a fine. If you're looking at if the cell phone is mounted or you're not actively engaged with the cell phone, that's not considered an offense. So the AI was trained to detect the actively engaged drivers with the cell phone. That's it. I think I went so fast through the presentation, but yeah, it was just very quick. I understand if you have a lot of questions.
Thank you so much. As a transportation engineer, it was amazing. If
Sure.
anybody has a question, please ask question in the chat box. And I have some question from the other students. The first question is, could you talk more about your work in Dubai with autonomous vehicle robotics?
Okay, so let me bring it up. The Dubai one was mainly a planning project. As I said, we wanted to help the Dubai government to select a technology, a self-driving technology, especially the shuttle, and evaluate and pick one technology for them. So we didn't really get into robotics. Our role was planning and evaluation and assessment of the technology and see if it meets the Dubai government criteria for selection.
Okay. And the other question is related to regarding the Colorado truck safety information system. Would the LED be the only way to get a message into the cab? If so, would it integrate into multiple ELD system? That seems like a quite challenge since there are many LED systems on the market from multiple vendors.
Okay. Yes, so all the trucks are mandated to have an ELD on their in their cab, basically. It's a federally mandated rule. So we thought, okay, all the trucks have to have it and let's utilize it. Although there are different brands or vendors, but these are standard ELDs, and when they are standard, you can communicate with them no matter what the vendor is. So, yep.
The other question, where was the name of the selected shuttle manufacturer? Where were they based?
It was Navia. Navia, the vendor name was Navia, and they're based in the US.
And the other question is regarding the South Dakota I-19 ITS system. Would information be shared to direct truck drivers to safe places to park once a warning is issued?
What was the question about truck parking?
It is related to would information be shared to direct truck driver to safe places to park?
In this project, we really didn't talk to the drivers. In South Dakota project, we didn't have any communication with the drivers. The Colorado one, we had communication with the driver. Not sure if they mean the Colorado one. But the parking information was not included. It was mainly safety messages for the drivers.
And how ITS technologies are selected? I understand this is project specific, but could you please give us an example for ITS technology?
Selection?
Yes.
It depends on the client criteria. Each client has different criteria for selection of a technology or a project. So one can be for sure the cost of a technology or a project. One can be the performance of that technology. For example, for the pedestrian detection technology that I showed you in Western Australia, we'll bring it up. This one, the selection criteria, we had, I guess, 10 selection criteria. Cost, performance of the system, delivery, like how fast they can deliver the system. I'm thinking what else was in the, these were the three main criteria to look at. And how is the customer support of the vendor, if they're a local presence of the vendor, and these are on the top of my head for the criteria. Examples, how we select different projects.
Okay. We have the other question. Have you ever done an integrated assessment of railway and truck cargo getting in and out of urban area surrounding maritime ports?
I do not have any railway experience, unfortunately.
Any question, everybody? The other question, what are the primary duties of an ITS lead, and what steps can someone take to prepare themselves for this position? It's a good question, I think.
Yeah, very. Yep. So my duties are mainly, I would say I cannot generalize it to every ITS engineer, probably everyone is unique, but my roles are mainly coming up with solutions for different problems that the client have. Like, for example, as I showed you, in different states or different countries, they come up with they have an issue, either safety, mobility, any transportation issue, and they want us to come up with a solution. We do the research, mainly I do the research. I evaluate different technologies that I can come across in my research, and then rank them for example, for the client, so that they can easily decide on which one to go with. And also writing is a big part of my job as well. I write reports on, as I said, the system engineering analysis is a heavy writing, needs heavy write-up for the final product. You have to write hundreds of pages to produce the documents, to document the problem that the client has, to document the solution that you propose. Everything that you do throughout the project, from the problem statement, solution evaluation, has to be documented and needs writing. I do presentations in different client meetings, conferences, so that's another part of my job. I would say 70% is focusing on the projects and write-ups, and 30% is presentations and meetings with the clients. There was another question. So this is the role. I explained what I do, but how to prepare? You need to be able to speak and write well. So speaking and writing are the two skills that you can improve for sure when you do your master's and PhD. Yeah.
Regarding the South Dakota I-19 ITS system, if there is an accident that would mean it is unsafe to continue travel, would the information communicated to the truck driver include information on safe places where they can park their large vehicle, where they
okay,
when
okay,
they
got
exit
it.
the
Yes.
highway?
Yes, so there was a part of the project was traveler information system. It was mainly through the dynamic message signs. We didn't have in-cab messaging, but we did have dynamic message signs to show the truck drivers about the parking location. There were maybe 2 parking locations in the whole corridor. So it was not really efficient, I would say, because dynamic message sign in general to me is not very efficient, but we did post about the parking locations, the weather condition, and if the roadway is closed or not, that type of thing. Yeah, but it was not in cab.
Well, he repeats again his question. He mentioned that my question about maritime ports and railroad cargo was about the impact this has on traffic management in cities surrounding large ports.
We didn't specifically look at this, the traffic and impact near ports. But I would say it's similar to other, like, for example, if there is a hub, like a transportation hub, a metro station, it would a similar impact, kind of similar impact on the traffic and transportation network. But in terms of railroad, I have not worked on that railroad project, but my colleagues have worked on a similar type of thing that he's talking about. Mainly, we looked at how we can inform the drivers about the train coming, what time the train is coming, because the train intersection with the roadway would create a huge delay in the network, and we want the drivers to know about it and plan accordingly. We had a project to do basically install cameras near that intersection and observe the train, inform the drivers, talk to the train station, that type of thing. But other than that, I would say the impact is similar to any other impact that a transportation hub would have.
Is there any application of ITS in private industry?
Yes, although most of our clients are public agencies like state DOTs, but there are private entities. Like, for example, we had a project with Disney last year, which is a private entity, and we, although this project was confidential, we were not allowed to talk about it, but I can just give you a blurb. Have you tried the Star Wars ride in Disney? If you have tried, we worked on that to make it more, to make the cars, there are some cars in the show, in the ride, and we wanted to improve the navigation of those cars so that they can self-drivingly navigate and go. And for now, they have a track, they have magnetic sensors, and through using that magnetic sensors, they would go and continue the ride. But we wanted to make it self-driving and autonomous, and that was an example of an ITS project for a private entity.
Okay, I think there is no any question. And I forgot at the beginning of this webinar, I introduced myself and my members group, Annika. I'm a PhD student under the supervision of Dr. Kaiser. Dr. Kaiser is chair of Department of Civil Environmental Engineering, but he was on the trip, unfortunately, and actually my advisor faculty is Dr. Melli. He was sick and unfortunately he couldn't participate in this webinar, but it was so amazing for me as a transportation engineer. Yes.
Sure.
And
I'm
thank
glad.
you for coming and joining.
Sure, it's my pleasure. Thanks for having me today. And I hope you got some insights into what transportation engineers do. And if you have any questions, just don't hesitate and send me an email. I would be happy to answer your questions.
Thank you. And I hope in the near future we have a more webinar and seminar, because your topic is really interested for me and the other student, I think, because you know, it's the new topic and concept.
Yes. Yeah, sure. I would be more than happy.
Thank you very much.
Okay.
You're welcome.
If anybody doesn't have any question, so I think it's you can leave, and yes. And thank you again for coming and joining, Dr.
Absolutely. Absolutely. Have a great rest of your day, you all.
Thank you so much.
Thank you. Bye-bye.
Have a great time. Bye.
Bye-bye.